This week you finished your first exam in class, and so you're going to take a moment and grade your exam. Each problem is worth 5 points. If it has multiple parts of that problem, then each part is worth 5 points. Go ahead and give yourself 5 points if you got the problem correct and you showed your work and it's easy to follow. So the first problem, in each case, sketch a graph with the given characteristics. And so we're given that f of 4 is undefined and the limit as x is approaching 4 of f of x is equal to 2. Okay. So since f of 4 is undefined and we know that we're approaching, hopefully that will start writing. So let's look at this when x is equal to 4. The limit is approaching 2, but it doesn't exist. So let's put an open circle at 4, 2. And since the limit exists and it's approaching 2, it has to be approaching, as x is approaching 4, your y value has to be getting closer and closer to 2, but not existing. So there's multiple ways that you could have gotten this graph, and that's just one example. So the next one says that f of 3 is equal to 2. So let's go ahead, when x is equal to 3, let's put a point at 2. But then it says, and x approaches 3 if f of x does not exist. So we know we have a point here. We could have something where it's approaching maybe 2 on the left of x equals 3, and then we have some jump in the graph. So the other side is not coming in and approaching y equals 2, as x is approaching 3 from the right. So part C says f of 1 is equal to 3, and the limit as x is approaching 1 of f of x is equal to -2. So f of 1 is 3. So let's go ahead and plot that point. But we're approaching -2 as we look at the limit as x is approaching 1. So we're going to have an open circle here, and the graph has to come to it on the left and to the right, but never actually get there. So that's the first problem. That's worth 15 points altogether. So for problem 2, you're looking for the limit and evaluating the limits. And so the first one, we're looking at the limit as x is approaching -1 of x plus 1 quantity squared all over x squared minus 1. First thing that you want to do when you're evaluating limits is we want to go in there and we want to just directly substitute. I'm going to try writing on the screen below because my screen keeps jumping. And so let's see if that works even any better. And so, again, we're going to plug in -1 wherever we see an x. And so if we do that, we get back -1 plus 1 quantity squared all over -1 quantity squared minus 1. And so when you use order of operations and you simplify this, in the numerator we get 0 squared, which is 0, all over the denominator -1 squared, which is 1. 1 minus 1 is 0. So recall, if you get the form 0 over 0, that's an indeterminate form. This doesn't tell us anything about the limit, and we need to go back and we need to see if we can manipulate it. So in this case, I notice that I can factor the denominator. So let's factor the denominator. And so again, we're looking at the limit as x is approaching -1 of x plus 1 quantity squared all over our denominator, x squared minus 1. So let's factor x squared minus 1. That's a difference of squares. And so this gives us x plus 1 all times x minus 1. So notice now that we have a factor of x plus 1 in the numerator and 1 in the denominator. So we can cancel out the one of the ones in the numerator. And so looking at this, we have -1 plus 1 in the numerator all over -1 minus 1. So if we simplify this, we get 0 over -2. This is okay, which is equal to 0. So for 2a, you should have gotten back 0. You should have shown your work in a neat, organized manner. You should have used one of the methods that we have learned in class. If you have used a method that we have not learned in this class, it's not acceptable. So now let's look at B. Let me move it over here. So 2b, we're looking at the limit as x is approaching 9 of the square root of x. Outside of the square root of x is -3. And then all of that is put over 9 minus x. So again, we're going to go in and we're first going to try direct substitution. And so when we do this, we get the square root of 9 minus 3 all over 9 minus 9. So substituting or simplifying, we get square root of 9 is 3, 3 minus 3 is 0, all over 0. So again, we get the indeterminate form, and we need to go back and manipulate this so that we can see if we can find the limit. And so we have a radical in here, and so let's try multiplying through by our fancy one, which is the conjugate of the square root of x plus, or minus 3, which would be square root of x plus 3. Okay, so looking at this, we're going to distribute. We have a difference of squares up there, and so basically this is the limit as x is approaching 9. This is the square root of x quantity squared, which is x, minus 3 quantity squared, which is 9, all over 9 minus x. I'm not going to distribute in the denominator. Square root of x plus 3. Again, if you go in here and you plug in 9, we'll still get 0 over 0. But notice that that numerator, x minus 9, that quantity is almost identical to the 9 minus x in the denominator. And so we can factor out a -1 to make it identical. And so let's rewrite this. This is the limit. As x is approaching 9, we're going to pull out a -1. And this is going to be now the same thing as -x plus 9, or 9 minus x is another way to write that. All over 9 minus x, that quantity times the square root of x plus 3. So now we can cancel these like factors. And when we look at this and plug in 9 for x, we get -1 in our numerator all over the square root of 9 plus 3. Well, square root of 9 is 3. And so we get -1 all over 3 plus 3, which is 6. So this limit, as x is approaching 9, is going to -1/6. So problem 2 was worth 10 points. Each part was worth 5 points. Again, give yourself full credit if you've gotten the correct answer. You showed your work, and you used a method that we used in our class. So problem number 3, we're finding the derivative of f of x equals the quantity 2 minus 3x. That quantity is squared. We're looking at the derivative, finding this with 4 different methods that we used in this class. And so the first part, A, was looking at the derivative of f of x by first expanding it. And so if we expand f of x, we want to rewrite that. This is the same thing as 2 minus 3x, all times 2 minus 3x. And so expanding this, let's FOIL this out. 2 times 2, this gives us 4. 2 times negative 3x is negative 6x. Distributing the negative 3x, we get negative 3x times 2 is negative 6x. And negative 3x times negative 3x gives us plus 9x squared. Let's rewrite this. Descending order of powers and combining like terms, we get 9x squared minus 12x plus 4. Combining those two terms. And so now it's in the form that we can just go ahead and take the derivative. So let's bring down our power down front. 2 times the coefficient in front, 9, gives us 18. Subtract 1 from our exponent, so the derivative of 9x squared is 18x. Looking at the derivative of negative 12x, bringing our power down front, which is 1, times that coefficient of negative 12 is negative 12. Subtract 1 from our power, the x goes away. And a derivative of constant is 0. And so f prime of x, you should have gotten 18x minus 12. So part B, we wanted you to use the product rule. And so let's rewrite f of x as a product. F of x could be rewritten as 2 minus 3x, all times 2 minus 3x. So you want to use the product rule when we're taking the derivative. And so we have f prime of x is equal to the derivative of the first function, 2 minus 3x. Well, derivative of a constant is 0, and derivative of negative 3x is negative 3. All times the second function, which is 2 minus 3x, plus the first function, which is 2 minus 3x, all times the derivative of the second function, which is negative 3. So let's go ahead and distribute the negative 3 inside the parentheses in each case, and then combine like terms. So we get the derivative is equal to negative 3 times 2 is negative 6, negative 3 times negative 3, x is plus 9x, plus, distributing the negative 3, we get negative 3 times 2, so that's actually minus 6. And negative 3 times negative 9x gives us plus 9x. So combining like terms, we have 9x plus 9x is 18x, and negative 6 minus 6 gives us negative 12. You know, if we did this and got a different answer than the above, then something was off. Okay, so part C says find the derivative using the chain rule. And so using the chain rule, again, we had 2 minus 3x quantity squared. So taking the derivative using the chain rule, let's bring the 2 down front. This gives us 2, all times the quantity, or what was inside, 2 minus 3x. Subtract 1 from our exponent, which is 1. And then multiply by the derivative of the inside. And the derivative of the inside is negative 3. And so we have this negative 3 times this 2 out front is negative 6, all times the quantity 2 minus 3x. Let's distribute it. So we get negative 6 times 2 is negative 12. Negative 6 times negative 3x gives us plus 18x. So we just found that the derivative is the same thing as above. And then the last way that you wanted to do this was using the difference quotient, the formal definition of a derivative. So we're looking at the limit as h is approaching 0 of f of x plus h. Okay, so remember this was 3 minus 2x quantity squared. So wherever we see an x, we're going to replace this with x plus h. So we have 3 minus 2. I see an x there. I'm going to replace that with the x plus h. And then we have this quantity squared. So that's our f of x plus h minus our f of x function, 3 minus 2x, quantity squared, all over h. So we want to go through here and we want to clean this up and combine like terms in our numerator. So let's first distribute our negative 2 inside the parentheses. And so doing that, let's bring down our limit because we haven't taken it yet. The limit is h is approaching 0 of 3. So negative 2 times x, so that's minus 2x. Negative 2 times h is minus 2h. This is a quantity squared, so we want to write this out twice. And so I'm going to just rewrite this out here. So 3 minus 2x minus 2h minus, and then we want to distribute this 3 minus 2x times 3 minus 2x. So if you do that, 3 times 3 is 9. We had that negative 6x minus 6x is minus 12x. And then negative 2x times negative 2x gives us that plus 4x squared. And then this is all put over h. So the limit is h is going to 0. And so now we have to distribute this. So 3 times 3, that's going to give us 9. 3 times negative 2x is minus 6x. 3 times negative 2h is minus 6h. Now distribute the negative 2x to each term. We got negative 2x times 3, that is minus 6x. Negative 2x times negative 2x is plus 4x squared. Negative 2x times negative 2h is plus 4xh. So one more term we have to distribute, this negative 2h. Negative 2h times 3, so that's minus 6h. Negative 2h times negative 2x is plus 4xh. Negative 2h times negative 2h is plus 4h squared. And now let's distribute this negative inside this bracket over here. I need to make this a little smaller. So this gives us minus 9 plus 12x minus 4x squared all over h. So things should clean up really nicely and things should start canceling and all the terms on top should just be left with an h if we did this right. So we have 9 minus 9, those cancel. We have a negative 6x minus a 6x. That's minus 12x. Plus this 12x cancels. Here we have a 4x squared, and here we have a minus 4x squared cancels. So what we're left with up here is this negative 6h minus 6h. That's a minus 12h. Here we have a 4xh plus a 4xh. That's a plus 8xh. And a 4h squared all over h. So notice they all have an h that we can factor out in the numerator and cancel it with a 1 in the denominator. And so if we do that, we get negative 12 plus 8x plus 4h. And so now when we look at this as h is approaching 0, we're left with negative 12 plus 8x. So our derivative is 8x minus 12. Okay, so the directions asked you to circle the part that you thought was the easiest to find the derivative. Which method did you like the best? And so doing and circling one of those parts, this was part C. Give yourself an extra credit point. And this was part D. I personally think that using the chain rule was the fastest and easiest way. Okay, so let me pull up number 4. So number 4 says, find the equation of the tangent line on the curve f of x equals the square root of the quantity 5x plus 6 underneath that radical. And then we're trying to find the equation of the tangent line at x equals 2. So first thing that we want to do, well, we need to have a point. So let's figure out what f of 2 is. So we want to go in and we want to plug in 2 wherever we see an x in our f of x equation. And so we have the square root of 5. I see an x there. I'm going to replace that with 2 plus 6. So this is equal to the square root of 10 plus 6, which is equal to the square root of 16, which is equal to 4. So we have a point at 2, 4. Okay, so we're going to need this when we find the equation of the line, but we need to know what the slope is at x equals 2. So to find the slope, we're going to look at the derivative. And when we look at the derivative of f of x, let's first rewrite it so that that radical is as an exponent instead. So instead of writing it as the square root of 5x plus 6, we're going to write it as 5x plus 6, all raised to the 1/2 power. And so now when we take the derivative, we can use the chain rule. Let's bring our power down front. 1/2 of the inside, 5x plus 6. Subtract 1 from our exponent. So 1/2 minus 1, or 1/2 minus 2/2 is negative 1/2, all times the derivative of the inside. And the derivative of 5x plus 6 is 5. So we find that the derivative is equal to, we have 5 left in the numerator, all over 2. Let's bring this down to the denominator to make that exponent positive, and we can rewrite it as a radical. So the square root of 5x plus 6 down there in the denominator also. And so now we want to figure out what that slope is at x equals 2. And so we're going to go in there, and wherever we see an x, we're going to replace it with 2. And so we have 5 all over 2, square root of 5. I see an x there, replace it with 2 plus 6. So this is giving me 5 all over 2, square root of 16, which is 5 all over 2 times 4. So we get that that is equal to 5/8. So our slope when x is equal to 2 is 5/8, and that's going to be the slope of our tangent line. And we have the point 2, 4. So you can use the point slope formula, or we can just go in and figure out what b is using the slope intercept formula. And so we have y, which is 4, is equal to x, which is 2, times our slope, 5/8, plus b. So 4 is equal to 10, or I guess that reduces. So this gives me 5/4 plus b. We want to get b by itself, so let's subtract 5/4. As we're doing that, we're going to need a common denominator. So this is 16/4 minus 5/4 is giving us b. And so b here is 9/4. So the equation of our tangent line is y is equal to our slope, 5/8 x plus b, which is 9/4. So this is what your answer should be. Go ahead and give yourself full credit again if you got the correct answer and you followed all the steps correctly and you showed your work in a neat, organized manner. So number 5 has multiple parts, and it says find the derivative of the following functions using rules that we've done in class. And so let's rewrite f of x a little bit to help us take the derivative of this. So let's get rid of that radical and rewrite it. in the equivalent form with a exponent. And then let's also rewrite 1 over x cubed by bringing this up into the numerator. And so we have f of x is equal to x cubed plus x all raised to the 1/3 power plus x all raised to the -3rd power plus 3. So now this should be pretty easy to take the derivative. Let's bring down our power down front, just using our general power rules on all of these. And this gives us 3x squared plus 1/3 x, subtract 1 from the power. So that one, we need a denominator of 3. So 1/3 minus 3/3 is -2/3. I thought I was going to sneeze, sorry, excuse me. And then let's take the derivative of x to the -3rd power. So bring our exponents down front, -3x, subtract 1 from our exponent is going to give us a -4. And then the derivative of 3 is 0. So let's clean this up a little bit. We didn't have any negative exponents in this, and we had radicals. So let's just rewrite this. Derivative f prime of x is equal to 3x squared. 1 is going to be plus 1 is going to be left in the numerator, 3x, and the 2/3 power is the same thing as the cubed root of x, and that is squared, minus 3 all over x to the 4th power. That is 5a. 5b. We have the following. F of x is equal to x to the 5th plus 6x cubed minus 2x. And that is all over that whole quantity I just gave you, x squared. So there's a couple ways that you could approach this. We could use the quotient rule, but I noticed that we're dividing by a monomial. So let's just divide each term in the numerator by x squared and rewrite it, and then we can just use that general power rule. And so doing that, we would get f of x is equal to, well, x to the 5th over x squared, that gives you x cubed, plus 6x cubed over x squared, that would give us a 6x, minus 2x over x squared, that's going to give you 2 over x, or 2x raised to the -1 power. So taking the derivative now, we can just use the general power rule, and x cubed, the derivative of that is 3x squared, plus the derivative of 6x is 6, and then the derivative of -2x to the -1 power, bringing our power down front, -2 times -1 is going to give us plus 2x, subtract 1 from our power, we get -2. So our derivative here is equal to 3x squared plus 6 plus 2 all over x squared. Or if you use the quotient rule, so let me just go through it using the quotient rule. If we use the quotient rule, we need to take the derivative of the numerator. So derivative of the numerator gives us 5x to the 4th plus 18x squared minus 2, all times the denominator, x squared, minus that whole numerator. Shrink this a little bit so I can fit it in. Our whole numerator, which is x to the 5th plus 6x cubed minus 2x, all times the derivative of the denominator. So derivative of x squared is times 2x, all over the denominator, x squared quantity squared. So notice how that other way was a lot easier. We have to clean this up a little bit, combine like terms. So let's distribute it in the numerator and combine like terms. So x squared times 5x to the 4th, that gives me a 5x to the 6th. X squared times 18x to the squared is 18x to the 4th. X squared times -2, so that's minus 2x squared. Let's distribute this -2x to each term inside. So -2x times x to the 5th is -2x to the 6th. -2x times 6x cubed, that's -12x to the 4th. And -2x times -2x is plus 4x squared, all over power to power multiplication. And so this would give me x to the 4th power. Combining like terms, 5x to the 6 minus 2x to the 6 is 3x to the 6. And 18x to the 4th minus 12x to the 4th, that gives me plus 6x to the 4th. Negative 2x squared plus 4x squared, that gives me plus 2x squared, all over x to the 4th. So notice that if we divided each of these terms by x to the 4th, we get the same thing that we got above. Just going to leave it in this form though. I guess, actually, technically we should pull out an x squared here. And that would give me 3x to the 4th plus 6x squared plus 2 all over x to the 4th. And then this cancels an x squared with 2 of them down here. And so really cleaned up form is 3x to the 4th plus 6x squared plus 2 all over x squared. Okay, so let's pull 5c. Now we have y equals e raised to the x squared minus 4x power. And so taking the derivative of e is pretty easy. All we do, so dy dx in our case, it's equal to the derivative of our exponent, which is 2x minus 4 times the e function itself, e all raised to the x squared minus 4x. So that was 5d was a natural log. Bringing it up now. We have g of x is equal to the natural log of 2x times e to the x. So we can go ahead and just take the derivative of this, but I noticed that we can use some rules of logs to rewrite this and make it a little easier before we jump in and take the derivative. So doing that, we have multiplication in between here, and so we can break g of x down. G of x is the same thing using rules of logs, the natural log of 2 plus, there's multiplication in between, we can rewrite it as plus. So the natural log of x plus the natural log of e raised to the x power. And then natural log of e to the x is just x, so we can even rewrite it and clean it up even more. So we have g of x equals the natural log of 2 plus the natural log of x plus x. So taking the derivative of this, well, the derivative of natural log of 2. Natural log of 2 is just a constant, so that goes to 0. Derivative of natural log of x is just 1 over what you were taking the natural log of, which is x, times the derivative of the inside, which is 1, plus the derivative of x, which is 1. This is what you should have. You might have had it where you did not do that and you used the chain rule. Within the chain rule, though, you would have to use the product rule. If you had done this and you had gotten a common denominator, this would have given us 1 plus x all over x. So that was number 5 that had 4 parts. Now let's look at number 6. Problem 6 states, the profit in dollars from sales of X car seats for infants is given by the following function. P of X is equal to 4x minus 0.025x squared minus 5,000 for values of x between 0 and 2,400. Part A, we want to find the average change in profit if the production is changed from 800 to 850 car seats. So we want to find the average rate of change. So basically all we want to do is we want to find the slope there. We want to look at what is P of 850 minus P of 800 all over 850 minus 800. So we need to go in here, we need to evaluate and figure out what P of 800 is. And so if you go in and you plug in 800 wherever you see an X in here, you are going to get back negative 17,800. If you look at P of 850 and plug in 850 wherever you see an X in our profit function, you should get back negative 19,662.5. So the average rate of change, we have this negative 19,662.5 minus this negative 17,800 all over 850 minus 800, which is 50. So reducing, we get the numerator minus a negative, that's really a plus. And so we get negative 1,862.5 all over 50, which is giving us negative $37.25. So the average rate of change of profit from going from 800 car seats to 850 car seats is about $37.25. Part B says find the instantaneous rate of change of the profit of productions of level at 800 car seats and give your interpretation. So we want to find the instantaneous rate of change. We're just going to find the derivative of our profit function. So P prime of x is equal to, well, the derivative of 4x is 4 minus the derivative of 0.025x squared. Well, 2 times that, negative 0.25. That's going to give us minus 0.05x. And then the derivative of 5,000 gives us 0. And so let's evaluate this now, the derivative at 800. So we get 4 minus 0.05 all times 800. So this would give us back negative $36. So the instantaneous rate of change, the profit is going to be going down $36 when we make that 800th car seat. So the next problem, we're given the following. We're given that f and g are differentiable. We're given that f of 2 is equal to 3. F prime of 2 is equal to negative 1. G of 2, this is equal to negative 5. And G prime of 2 is equal to 2. So part A wanted the following. It wanted us to find f of g of 2, the derivative of this. Well, let's think about this. This is using our product rule. If we had this and we want to look at this, the product rule says we're going to look at the derivative of the first, f prime of 2, times the second, g of 2, plus the first, f of 2, all times the derivative of the second, g prime of 2. Didn't matter in order here. That's just the process that I do it. And so we need to look at what is f prime of 2. So this is -1 all times g of 2. G of 2 was -5 plus f of 2. F of 2 is 3 all times g prime of 2, and g prime of 2 was 2. So doing this, we get -1 times -5, this gives me 5, and 3 times 2, this gives me 6. So 5 plus 6 gives me 11. Your answer should be 11. Part B, you want to find 5f plus 3g, the derivative of this, evaluated at 2. Well, this is just a sum, and so sum of two functions is a, I'm going to look at 5 times the derivative of f of x, but evaluating at 2, so f prime of 2, plus 3 times the derivative of g of x, but evaluated at 2, so g prime of 2. So we have 5 times, well, f prime of 2, we saw up here was -1, so times -1, plus 3 all times g prime of 2, and g prime of 2 was 2. So order of operation, multiplication comes first and then addition. 5 times -1 is -5, plus 3 times 2 is 6. -5 plus 6 gives us 1. So C, f of prime of 2. So we need to use the chain rule here. This is the same thing as looking at f of 2 and looking at the derivative of this. And so this is f prime of the inside, f of 2, all times the derivative of the inside, f prime of 2. Well, f of 2, if we look at f of 2 from above, f of 2 was 3. So let's rewrite this. This is the same thing as f prime of 3 times f prime of 2. F prime of 2 was the -1. So all times -1. So now let's look at f prime of 3. F prime of 3 was actually 7 times -1. Excuse me, equals -7. And the last one, let me go and pull those. So I just wanted to pull down what I had written up there before, and I guess I had forgotten to write that f prime of 3 was equal to 7. Okay, so now that we have that information right in front of us, so we can look at part D, and D wanted the derivative of the quotient f divided by f plus g of 2. So I notice when I do this, I'm going to need to use the quotient rule. And so the quotient rule says the derivative of the top, derivative of f prime of 2, of the bottom, so f of 2 plus g of 2, minus the top, so f of 2, all times the derivative of the bottom, which would be f prime of 2 plus g prime of 2, all over this bottom squared. So f of 2 plus g of 2, that quantity is squared. So f prime of 2 here, it was the -1. So we have -1 all times f of 2, which we were given was 3, plus g of 2, which we were given was negative 5, so plus a negative 5, minus f of 2 again was 3, times f prime of 2 is negative 1, plus g prime of 2 was 2, all over that denominator. F of 2 again is 3, plus g of 2 was negative 5, quantity squared. So order of operations, we have negative 1. So inside this bracket here, 3 plus negative 5. 3 minus 5 is negative 2. Negative 2 times this negative 1 right there is 2. Minus negative 1 plus 2. So this is 1. So negative 3 times 1. So minus 3 all over 3 minus 5, which is negative 2, and that negative 2 is squared is 4. So we get 2 minus 3, which is negative 1 all over 4 is our last one. Okay, so that was your first exam. You want to go through and you want to sum all the points that you got for each piece. And then you want to go to the top of your exam and put your score on top of that. And then you want to upload your graded version to Canvas assignment. I hope this helped. See you in class next week. Bye.